Welcome back to the Learning Studio. You're watching our mathematics series where we uncover the most powerful concepts that shape science, technology, and the future itself. If you haven't yet, make sure to follow us by clicking the link below. And remember, the full playlist is also linked in the description so you can watch all the episodes in order. In today's lecture, we're diving into one of the most fascinating and useful fields of mathematics, calculus. Now, you may remember calculus as those endless derivatives and integrals from school. But in truth, calculus is the secret engine behind optimization, gradient descent, and even the way machines learn on their own. Let's start with a simple question. If you wanted to climb the tallest mountain, how would you know which way to go? You could look around, find the direction where the ground is sloping upward, and keep walking that way until you reach the peak. That's exactly what calculus does. It helps us find slopes, understand rates of change, and determine maximums and minimums. Whether it's finding the fastest route, optimizing an engine's performance, or training a neural network, calculus is always working silently in the background. Here are the basics you need to know. Differential calculus. This is all about change. Derivatives measure how fast something is moving or changing. In AI, derivatives are used to see how small changes in weights affect the performance of a model. Integral calculus. This is about accumulation. Integrals add up tiny changes to find the total. For example, integrating speed over time gives you distance. In machine learning, integrals can help us understand continuous probability distributions. Optimization. Calculus allows us to find where a function reaches its lowest or highest value. In AI, this means finding the best set of parameters that make the model perform well. Connecting to AI/ML, gradient descent, and backpropagation. Now here's where it gets exciting. Training a neural network is basically an optimization problem. We want to minimize error, the difference between the network's prediction and the actual answer. But how do we minimize it? That's where gradient descent comes in. Imagine standing on the slope of a valley. The derivative tells you how steep it is and which way is down. Gradient descent uses this information to take small steps downhill again and again until it reaches the lowest point, the global minimum of error. And how do we adjust every single weight in a neural network? Through a process called backpropagation. This is where derivatives are used layer by layer, calculating how much each weight contributes to the error and then updating them to make the models smarter. Without calculus, machines wouldn't learn, they would just guess randomly. So calculus isn't just about solving textbook problems, it's the language of change, the mathematics of optimization, and the key to how AI improves itself. In our next episode, we'll move into another powerful pillar of modern mathematics, probability theory. We'll explore random variables, distributions, and conditional probability, the tools that let us deal with uncertainty, make predictions, and understand data in the real world. Don't forget to follow us by clicking the link below and check out the full playlist in the description to keep learning step by step. The journey into the world of mathematics has only just begun.